Tanium's Discover module is a customer favorite because of all the unknown devices it finds on your networks. We'll find out how it works and how to tune it for the best results in your environment on today's Tanium Tech Talk. Welcome back to Tanium Tech Talks. I'm your host, Ashley McGlone, and Tanium's Discover module is one of the oldest and most popular with our customers. Now, just because it's old doesn't mean it's stale. There's lots of innovation going on there, and there are legendary stories of the kinds of devices folks discover on their corporate networks. It all goes back to the old adage, you cannot manage what you cannot see. But let's meet our guest today. Nash King is a Discover SME who's here to give us the tour. So welcome to the show, Nash. Tell us about your role.
I am a technical account manager. I've been with Tanium for about 2 years. And as a recovering network engineer, I kind of saw Discover and I was like, oh, that's going to be my thing. I'm going to do that. And then I went and did that. So today I just kind of want to talk about some of the things that I often talk to customers about, use cases, how to get the most information possible out of our little database of interfaces, interesting ways that we integrate with other Tanium modules, and frankly, a bunch of nitty-gritty to make your Discover experience as excellent as possible.
Welcome to the show, Nash. Let's dive in. First off, what is Discover for those who may not be familiar?
Discover is a network discovery tool leveraging your Tanium managed endpoints. It is at its root a scanning capability combined with a database of network interfaces that we find in your environment. One thing to keep in mind, it is not a database of endpoints. These network interfaces can be correlated to endpoints, but it's not the same thing.
I know that's a really important point for our audience here, for those who are new to Discover, because you see all these interfaces and you look at the numbers and you think, well, that's how many endpoints, but not exactly. That's a good clarification, because one endpoint could have multiple interfaces. And it may not be a Windows or Linux or Mac box either. So that's what really makes this interesting, is the kinds of things you find. So what kinds of, I mentioned in the opening, we've got these legendary stories. What are some, this is the fun thing when we talk about Discover, right? So what are some of the fun things you found on customer networks?
I have customers who found things like webcams that had default credentials that were aimed at places they should not ought to have been. I've got customers who found devices that they are not allowed to have on their networks due to requirements like NDAA, the National Defense Authorization Act, Section 889. I have heard tell of customers who found servers that had been walled up, just got left in a room and someone put up drywall and left there. They were able to provide a MAC address to the network team, who were able to hunt that MAC address down through the switches and eventually find the switch port it was connected to and follow a cable. Typically, people want to know about missing assets like that, or just unexpected things like that. I've got one customer who is tracking the rollout of hand scanners by looking for when they show up on the network and get discovered by a Tanium managed device. And I've also just got customers who, go, what can I manage that I'm not managing? So we have a whole lot of fun stories, but honestly, the real cool stuff is finding things you can manage with Tanium and keeping them under management.
I'm really interested to see where this is going. So don't let me stop you. Let's go.
This is the Discover workbench. Just kind of the overview page here. You can see we have a couple of handy dandy little trends charts. You can see at a glance the scan profiles that you have configured. You can also check on your imports. Green check mark, good. Purple clock means it hasn't happened yet. It's a red X, not so good. Ideally, your overview will look something like this. You can also mouse over and see when things are scheduled to take effect.
And so that's just like a background job that kind of
That's just a background job.
Data. Okay.
Yep, happens automatically. On premise, you can kick it off manually. In the cloud, we take care of that for you. So you have your scan profiles, and import has taken place. Now you have stuff in Discover. You can see here we've got a mixture of managed and unmanaged interfaces. These are all sorted by manufacturer. These ones that are marked as unknown have had randomized MAC addresses applied. You can tell if it's randomized if the second digit of the MAC address is 2, 6, 8, or alpha. So A is in alpha. This is commonly used as a privacy measure with things like iOS, so like Apple iPads and iPhones, and Android devices such as tablets and phones. You can also enable it. In this case, we've enabled it in our data center to just sort of make things a little bit more private. You can also do it in Windows, the operating system. It's a little bit more tricky with Macs. You will find this in environments that really think about what happens when my managed devices go wandering around. You may not want a random public Wi-Fi to be able to associate a MAC address with a specific endpoint. If you see unknowns, that's probably why.
Well, thank you, because I wasn't aware of that. I learned just now. Thank you, because I've been doing this for years, and I've just now heard about this randomized MAC address because I have a number of devices, and I didn't realize that, because I always wondered, why is that number so much bigger? Aren't there manufacturers for all these things? Now I know. Thank you.
Yeah, this has become more common in the last few years, especially since like Apple and Android and even Windows kind of turned it on as a default setting in a lot of cases. We use the first 6 digits of the MAC address to identify the manufacturer. This is called the OUI. In this case, you can see VMware, it's 000C29. The other 6 digits are randomized. This creates a number that is usually unique. Because this is usually unique outside of certain settings like Hyper-V, that it's been set up to kind of randomize its MAC addresses, but still use the Hyper-V OUI. We use this as our primary key within Discover. So a lot of folks think of the host name or even the IP address as the identifier. This is what says this is this computer. That's not how we think about it, because those things can change. If you've got DHCP in your environment instead of static IP addresses, and believe me, you have DHCP in your environment unless you're working someplace very, very strange. IP addresses change. The host name, we do a best effort attempt to resolve that using your DNS. But if your DNS is slow or it has a lot of cruft and is kind of out of date, your results here will reflect that. So hostname, we make a best effort to identify it, but we depend on your DNS being accurate. MAC address we get from doing one of our distributed scans or doing a satellite scan, and I will define these in a moment, from a device that is on the same subnet as the device that's being scanned. Generally speaking, once a packet hits a router, the MAC address gets stripped away. So if you are scanning from another subnet, you won't have a MAC address, but scanning within the same subnet, which is what you'll be doing with distributed scans, which is our recommended method, totally fine. So you get your MAC address, you'll get your IP address. If you're using NMAP, you will get open ports. We make a best effort to identify OS platform. With NMAP, we are reliant on NMAP's native capability to identify the OS platform. This is most accurate when you have an open port and a closed port. So this one has 3389 RDP and 5357. I don't know. I don't care. Open. And we know it has closed ports because, well, we've scanned like a top 1000 ports and it only shows 2. So I'm pretty confident that this is Windows.
Yeah, being a Windows box, it's going to have, 139 and a lot of other common ports that should be open normally. So you can see those are closed. One of the things that I learned when I was first learning Discover as well was that ping response packets have certain payload lengths by operating system that are unique. And there's all these clever ways, more than just even the ports, to identify. And I learned a lot just realizing, the OS signature sometimes is just encoded in the way the data is shaped in the packets. It's fascinating.
It's kind of a pattern match. So for ping, we are pattern matching on certain responses that we get back to the ICMP packets that we're sending. Obviously, for the ping scan, you need to enable ICMP in your network, which personally, I recommend enabling the ICMP packets necessary for ping anyway, because it's a useful troubleshooting method. But so yeah, we look at how the operating system responds. You can see the discovery method. And again, I will go into these in a moment. You can see your last seen. You can see labels that have been automatically or manually applied. I will go into these in a moment as well. And if there are things you want to know that you're just not seeing here, if you click on our little French fry menu, you can scroll through and there's a lot of options. Not all of these columns will be populated for every interface. Some of the cloud columns will not be populated, especially if it's, a physical device. If it's not a satellite scan, you won't have a satellite ID, but there is additional information there.
I like the first scene and last scene there. So
very
last
helpful
there, but first scene also, how long has this device been running around and we haven't done anything with it? Those are some great, great ideas.
First and last manage are also helpful, just in case you're wondering, this device hasn't reported in for a while. When is it reported into the Tanium server for a while, but we've seen it on the network. When is the last time it reported to the Tanium server? The answer here is determined by a pair of Discover saved questions. Basically, we just ask endpoints for a whole bunch of sensors and then shove their answers into this database. You can do some quick filtering. This just shows our managed interfaces. Unmanaged, this is helpful for thinking about what might I be able to manage that I'm currently not. And then we have unmanageable, which is things you can't put a Tanium client on, like a printer. If you mark things as unmanageable, either manually or automatically, it enables you to filter them out so that when you're looking for those potentially managed devices, you can just ignore them. You're also able to actually ignore certain devices, but I don't recommend using this in most cases unless you absolutely know you do not care. Unmanageable is usually what people are looking for when they're trying to use ignore. You can also take a quick glance and see who's got tags or labels. Who's got labels? These all have labels. We've got 7 that have no labels applied. You can always look through that and think, how can I categorize things to be more useful to me? Let's go talk about scan profiles so that I can then talk to you about the cool stuff that is labels.
That's what I wanted to ask you was there's a lot of really cool data there. How do we get all this data?
You do not, in fact, need a bunch of servers anywhere. You do not necessarily need specific devices running a scan outside of circumstances where you need a satellite. We have 2 primary scan types in Discover for cloud. You've got distributed, which is when endpoints in a linear chain will scan the gaps in between themselves and their nearest neighbor Basically, the first endpoint in that chain is going to look at all of the IP addresses that are lower than it. So if it's at 20, it's going to scan from 1 to 19 behind itself so that you get full coverage of the subnet. And I'm going to talk here like it's a /24, which has 254 usable IP addresses. So it'll scan behind itself. So you got 20 and it's scanning behind itself from 1 to 19. Then it knows that its next neighbor is at 30. So it's going to scan forwards into that gap, which would be 21 through 29. Because we're breaking the scan down like this, it makes it a little less disruptive on the network usually, and it's a lot less effort for an individual endpoint, and it's a lot faster. Scanning 10 IP addresses takes a whole lot less time than scanning 254. Basically, this scanning forward continues until you reach the endpoint at kind of the end of the chain, and that endpoint will scan from it n+1, so its IP address +1, all the way to the end of the subnet. So if that endpoint is at IP address 200, it'll scan from 201 to 254. So you will get full coverage of that subnet. Within NMAP, we give you the ability to help reassure the folks who maybe don't like NMAP. You can specify a source port so that people can look at this traffic and go, oh, that's Tanium. Typically, we recommend 17,000. And when you create a profile, that should be pre-populated. When you do a satellite scan, this is going to be a single promoted endpoint that has some special capabilities. It will also be running an NMAP scan. And the only real difference is between it and a distributed is it does the whole scan itself, and it can scan subnets that it's not in. When it scans subnets that it's not in, you will not have a MAC address, but it's pretty good information and very helpful, especially if you've got, say, a new site that you're trying to onboard, or you've just purchased another company and you need to know what they actually have on their network because it might be scary. You can just set up a satellite and give it access to their network, tell it what subnets they use, and let her rip. A satellite scan can only scan up to 4,096 IP addresses, but that'll do you in a lot of cases. And you can create multiple scan profiles on a given satellite. We'll also run these in parallel to help speed things up.
Nice.
So that's NMAP. Typically, we recommend that you scan the top 1,000 ports. We get these from NMAP. You can also add specified ports, or if you definitely don't want to scan 1,000 ports because you might have something that gets upset, you could restrict it. You can also exclude ports. Some printers don't like it if you scan port 9100. You can exclude that and make your life better.
And by the same token, let's say, like, I know in manufacturing, there are certain applications that only operate on certain ports. And so maybe you want to add some specific ports in there that are known signatures in your environment so you can find those devices.
Yep, you can add them. Or if these devices are particularly sensitive, you could exclude the ports they're sensitive on, or you can actually exclude those devices. We typically recommend you scan all networks and then create specific exclusions, but you can also specify that a scan will only take place on either specific networks or computers that belong to a specific group are the only ones allowed to scan. One way to specify that, like, home users can't scan is to create a computer group that in cloud only includes endpoints that have NAT IP addresses that you know belong to the corporation. Or on premise, if a device is directly connected to the Tanium server, it won't have a NAT IP. So you can tell, it'll say that it's got none. So you can tell it, only include the group of computers where the NAT IP is none. It's kind of a simple and elegant way to exclude things. You can also do it, and that's an exclusion by exclusion, or by inclusion rather. You can also do specific exclusion based off of IP address and subnet, or for you on-premise people by zone server. If you are in cloud, you have this option. Please do not click it because all of your devices are connected to a zone server and you will not get the result that you want. I strongly recommend finding out from your network team what are the VPN subnetworks and excluding them. Honestly, you should also be isolating them within the broader isolated subnet setting to ensure that they don't do things like form a chain and pass Windows updates around to people who are at home. You normally want to exclude isolated subnets. You may have a circumstance in which you are using a distributed scan in a subnet that endpoint would end up isolated. Say if you wanted to do a ping discovery, which you cannot currently do with satellite. In that case, you would create a specific profile, target that specific endpoint in a computer group, and then uncheck the isolated subnet slash systems. You could also do it as a specific network. That will allow that single endpoint to scan, and then you can go out and take that information, install more Tanium, and you can use a regular distributed scan, and life is great. You can.
I really want to talk about this reissue here, because what I see some folks doing is like this every 24 hours over an hour scan everything, but you're just getting a window of 1 hour in your environment. Then what's your recommendations around how many times per day people should be running these scans?
24 times a day. Typically, we recommend a scan that gets reissued once an hour and is distributed over 30 minutes. And we typically strongly recommend against using scan windows, mostly because you will miss things. I understand that there are networks that are sensitive and cannot be scanned on a frequent basis. And while this makes me personally sad, I understand that you don't want to scan them and get yelled at. So please don't scan them and get yelled at. You'll have your distribute over, you'll have your reissue, please don't scan window, and that'll tell it how often to scan. And this is where I realized I forgot to tell you about the ping scan and the ARP scan.
Yeah, I was going to ask back at the top. This is really cool. I love the way they made this interface where you can see exactly what data is included in the type of scan you're going to run.
Yep, we give you a handy dandy little explanation. If you need to get data with the least amount of impact on the network possible, potentially even no network traffic whatsoever, that's when you use the ARP cache. It does exactly what it says. It looks at the ARP cache and pulls the information back from there. It is very limited on what it can return. It's just MAC address, IP address, and manufacturer. But you know what? Sometimes that's what you need. If you uncheck hostname resolution, it will be 0 network traffic. If you check hostname resolution, it is a small amount of traffic. We have a community article that breaks down just how large or how much data we're passing for each of these scans. So ARP, it can be no traffic. It gets you the least useful amount of data. Ping scan, it just uses ICMP echo. Please turn it on in your network. It will return MAC address, IP, manufacturer if the MAC address returns a valid manufacturer. And if you check hostname resolution, hostname. It makes an attempt to match for operating system. It's pretty darn good, but it's not perfect. This is the highest level scan that you can use on Solaris and AIX. They don't support NMAP. NMAP is our friend. We offer you a level 3 and a level 4 on NMAP. The level 3 uses NMAP to do its discovery, and it's a little bit more traffic than level 1 and level 2. But level 3 doesn't get you OS detection and port scanning, which I think are super useful. Level 4 is what I recommend to pretty much everyone. It is possible to persuade your security team and your network team to let you do this, I promise. If you're not sure how, you can always contact Tanium support and we will help you negotiate. One common thing is, well, we can help you find it if someone connects a rogue router or wireless access point to the network on one of the endpoint subnets. Network engineers like to know about these things. Rogue APs are not our friends. We don't like them. This will get you the best data. And again, NMAP is only available on Windows, Mac OS, and Linux. But you can do pretty good things with ping. So I think that's about it for profiles. So let's move on to my favorite, labels.
And folks, as always, we have a number of resources for you. So if you check the show notes below, we've got a link to docs, a link to some really handy community articles that will go into more details on explaining some of these use cases that we've talked about in this episode. Also, there's a link to a previous episode 29, where we talked specifically about the Discover satellite capabilities and go deeper on that. So please avail yourself of those resources. And as always, if you have any questions, reach out to your Tanium account team or Tanium support. We would love to help you maximize your use of Discover in your environment. So there you have it, folks. There's our overview of the Discover module. And until next time, go Tanium.